Okay, so we're looking at the second part of 2-3, correct? All right. So when you plot the motion of an object as velocity versus time, these are referred to as slope functions or the f prime graphs. In the study of calculus and physics, these graphs represent the rate of change at the original function. By analyzing these graphs, you can find where changes occur slowly or quickly by observing the rates of change or slopes of the tangent line at specific moments in time. Consider the function shown at the right. It should be at the left. Notice the curve at the first point, x equals negative, or x equals 1/2. The slope of the curve here appears to be about 1/1, which is 1, yes? Then at x equals 4, the slope has decreased to about 1/3. Yes? Mm-hmm. So this slope, would you say, is steeper or less steep than this slope? This is steeper than this, right? This starts to flatten out. So the slope is decreasing from here, yes? So, can you analyze and sketch the slope graph on the grid below? And it tells us a hint here. When x is 0.5, the derivative is 1. So when x is 0.5, the derivative would be about 1. And when x is 4, the derivative is about 1/3. Well, let's take this even further. If we had a point over here, say at 1/3, is that going to be steeper yet? Yeah, because if you look at this, our tangent line would be here. That's even steeper than this, isn't it? So we're talking about here, we would be someplace up in here.
Will the following students please come to the practice?
And
Callan Agan, Murphy Beck,
over here, it's going to be less steep, isn't it? So that means it would be smaller. And somewhere in between, it would be a little bit more here, wouldn't it? And you can kind of see this is decreasing at a slower rate, and it's increasing at a rapid rate over here, yes? So the graph of that would look something like this. Does that make sense to you? Compare the graphs of f and to the graph of f prime. The f prime graph gives us insight into the behavior of the original function. For example, at x equals 1, the slope of y equals f of x appears to be almost -2. So here, your slope, we're talking about a line right here. Yeah, that appears to be almost -2. Agreed? Therefore, on the y or the f prime graph, the value at x equals 1 is at -2. There are several relationships between the two graphs that are particularly important to note. Let's explore these features. So let's really look at this. Right here, or about right in there somewhere, probably more like in here, this is concave down, meaning opening down. Do you agree? Mm-hmm. And at this point, somewhere in here, it changes, doesn't it, to concave up? So this is concave down from what, -infinity to about 1.5-ish, 1.25, something like that. And then it's concave up from about 1.5 to infinity. Do you agree with that? And this right here, this is called a point of inflection. Now I want you to look at this point of inflection. Do you see where it might be something on the other graph? The what? The axis of symmetry, or what's that called? The minimum value there? Yeah. Isn't it? So that point of inflection kind of looks like it might indicate where our minimum's at. Do you agree? Something to really think about. What about this? This is a maximum on the graph, isn't it? Which tells me I would have a slope of 0. Yep. And so that would be what? Approximately -1, 0? Well, what happens here at approximately -1, 0? Yeah? So the maximum on your graph when your slope is 0 indicates a 0 on the f prime graph, doesn't it? Where it crosses the x-axis. What about this down here? Again, you'd have a slope of 0 on that one, wouldn't you? Your tangent line. And that's a minimum value, isn't it? And again, you can see here, it kind of coincides with this 0 right here, doesn't it? Also, when it's concave down, so from -infinity to 1-ish, from -infinity to 1-ish, what do you notice about that? If it's concave down, this is
decreasing.
Yeah. And when it's concave up, this is
Curious.
So you could graph your derivative function from an original function fairly well, yeah?
Yeah.
So, one relationship that I noticed and that I noted was that the derivative at -1 is 0 and the derivative at 4 is 0, which coincided with my maximums and minimums of my function. Yeah? And I think probably here it's going to investigate that a little bit more. So when we're looking at this, and I might have gotten, yeah, I got a little carried away on what I was talking about here, so we've kind of filled in a lot of these blanks, but let's continue. When the graph of the function is rising, we say the function is increasing. Rising from left to right. Yes, we always read from left to right. And when the graph is falling, we say it is decreasing. It's customary to read a graph from left to right, just like we normally read. So, starting at the left on the graph of f of x, state the intervals of x where the graph rises. What do you notice about the slope of the curve? So the graph that is rising, so where is f of x increasing? On what intervals is it increasing, going up from left to right? Yeah, -infinity, and I think it's actually maybe a little bit to the right of -1, but an estimate of -1 would be okay. I think they said it was like -0.9. Same thing, yes? But we're looking an estimate here. And where else is it increasing? Because it continues, like this now decreases, but then it comes back up, doesn't it? So where else is it increasing at? Yeah, around 4 to infinity. They said something like 4.2. Same thing, yes? Okay, and so what do we know about the slope on those? Yeah. The slope of the graph is positive. Okay. Starting at the left, state the intervals where x where the graph falls. What do you notice about the slope of those? So now we're talking about where is f of x decreasing. So f of x decreases on what? Where it's not increasing, so from -1 to 4, or they said -0.9 to 4.2. Same thing, right? And what do we notice about the slope? The slope of the curve is negative. Here. All right, how about C? At what values of x on the graph of y equals f of x does the function appear to have a maximum or minimum value? What is the slope at those points, and what characteristics of the f prime graph occur? So we talked about that, didn't we? So f of x has a relative maximum at, I'm going to say x is approximately -1, or x is approximately -0.9, whichever, and a relative minimum where x is about 4 or 4.2. We know the slope of the curve at these points is 0. And the f prime graph had x-intercepts or zeros at these points. Would that be fair to say? Make sense? Now look carefully at this one. Why does the f prime of x reach a maximum value near 1.5? Can you explain what occurs at 1.5? Well, we talked about that one, didn't we? At about x is 1.5 on f of x, the graph changes from concave down to concave up. And I'm going to put in parentheses point of inflection. Okay, so procedure to sketch an f prime graph from y equals. Describe how the slope changes from left to right along the curve. Notice the intervals where the slope is positive, negative, and 0. Write down changes as they occur from left to right on a number line. Notice where x-intercepts occur. Pay attention to where the function is above and where it is below the x-axis. So let's do one. So here, we are going to talk about G and what's happening at G prime. So as we go across here, there's something here at 2, negative 2, right? And then there's for sure something around here, I don't know, that's a little past 3, so I don't know, 3.2, 3.3, something like that. So on our number line, we're going to look at that. A says, mark the number line above to show the values where g of x changes from increasing to decreasing. I just did that, right? Changed from decreasing here to increasing here. At these x values, the slope of the curve is right here. That tangent line would have a slope of what? 0. So here, m equals 0. On the function, we refer to those values as extrema or relative, mins, or max. So here, we have a slope of 0, but here we also have a slope of 0, correct? Yeah? Okay, so the slope of this is negative. Do you agree with that? All the way to there, your slope's going to be negative, yes? It's decreasing. It's decreasing here, yes? So our slope of our G prime graph would be negative, yes? And then this changes and our slope would be positive here. That's an increasing function there. Therefore, our slope would be positive all the way across there of our G prime graph. And then here, again, this is decreasing. It's going down from left to right. And so if that decreases, we know the slope of the tangent line would be negative, yes? Now here's what I also want you to know. This is below the x-axis here. Yeah. That's not so important though. So let's not focus on that too much. Okay. Notice how the graph of g of x changes from concave up to concave down. So here, concave up, there's got to be a point of inflection somewhere in here. Somewhere, I don't know, somewhere in this general area someplace. So it's concave up, yes, opens up. And then at this point it starts to open down, yes? So notice how the graph of g of x changes from concave up to concave down. Estimate the x value where this occurs and place this value on the number line to the right. So we're going to place it over here on this number line. So this x value is what? It's not quite at 1. I don't know, maybe 0.8, 0.9, something like that. I'm going to say 0.8. So that point of inflection occurs at 0.8, and I'm going to actually put that not here, but over where 0.8 would be. So 0.8 would be someplace over here, right? That's my point of inflection. Now, we kind of looked at that over here somewhere. And we said when there's a point of inflection, that becomes a minimum or a maximum, right? So we know that's going to become a minimum or a maximum value. We got to figure out whether it's a minimum or a maximum though. Yes? So let's think about this. If this needs to be a negative slope, what do you think it's going to look like? That function's got to be increasing, doesn't it? Yeah? And then again, negative slope, that has to be concave up to concave down. When it's concave up, your function, your new function, your G prime function, will be increasing. Okay? And when it's concave, when the function, this function right here is concave down, this will be decreasing. So we don't necessarily know what the y value of this is. It's going to be someplace up in here. And we know it's a maximum because this has to increase and then decrease. Now, what did we learn over here about zeros? Where it has a relative maximum or minimum, those indicated zeros on our derivative, didn't it? So here we had a minimum someplace at -2, -6. So that means that there's going to be a minimum when x is -2, a 0 when the minimum is -2 here, yes, and a 0 here where we're at about 3.3 is what we said. So at that point, you could kind of sketch this. It's going to be a parabola that's upside down. It's going to look something like that. So it's when the function is concave up, this is increasing. When the function is decreasing or concave down, your derivative function, your f prime function, is decreasing. I keep getting my words mixed up. I'm sorry. Questions? So our point of inflection was our maximum or minimum. Yes? All right. Let's look at this derivatives from the table. I think this is the last thing we're doing here. So one last thing. We've seen it's possible to estimate the numerical value of a derivative at a single point by finding the slope of the secant line passing through the 2 points on the graph. Let's explore how this can be done using a table of values for a continuous function. You notice it said for a continuous function. If it wasn't continuous, we couldn't do this. Use the table of values for y equals f of x to find the derivative for each x value. Describe the behavior of the function and explain your reasoning. So you did this in your last homework assignment, didn't you? Where you use the 2 points, so -2 is what we're talking about, and so you use the 2 points around it to estimate the derivative. So the derivative at -2, we would estimate by finding the slope. So -6 minus 4 over -4 minus, or actually plus 1. So this gave us a positive 10 over a positive, well, negative over a negative, which gives us a positive, yes? Now, if that is positive, that tells me that the function is increasing. And therefore, when we have the point at -2, 2, the derivative of negative 2 is greater than 0. Yes? And then you could do the same thing for the next one. So here, the derivative at negative 1. So that means we're going to be using these 2 points, the ones that are surrounding it. We would have 2 plus 1 over negative 2 plus 0 or minus 0. And that gives us what? 3 over negative 2. So that means my function is decreasing. And at the point negative 1, 4, the derivative at negative 1 is less than 0, yes? For 0, we look at this. The derivative at 0 would be 4 minus 4 over negative 1 minus 2. That would give us 0 over negative 3, which is, so it's not increasing or decreasing, it's constant, yes? It'd be a horizontal line. So, at the point, what is it, 0, negative 1, the derivative at 0 would equal 0. And then when we do example 2, we could tell whether it's a maximum or minimum, because here we know that this has to be something, yes? And if this is less than 0, that means we're decreasing, and then we're going to move from decreasing to hopefully increasing, right? So let's look at this. At 2, we would have negative 1 minus 2 over 0 minus 3. That would be negative 3 over negative 3. Those turn to positive, and we would be increasing. So at the point, what, 2, 4? The derivative of 2 was greater than 0. So it did go from decreasing to increasing. So that means that we're going to have some sort of relative minimum because f of x goes from, what, decreasing to increasing. So we had to use both this and this to figure that out, though, right? We knew something was going on, but it's a minimum because we went from decreasing to increasing. All right, 3, the derivative of f at 3, we would be using these. So we'd do 4 minus 0 over 2 minus 8. So 4 over negative 6, which means this is decreasing. So at the point, what, 3, 2? The derivative of f at 3 would be less than 0. So important facts and findings. If the derivative of f prime of x is less than 0, then the graph of the function is decreasing at the x equals a, yes? And if the f prime of x is greater than 0, then the graph of the function was increasing at x equals a, yes? A relative minimum occurs on a function if the derivative of, or the f prime of x is 0, and the derivative changes from positive to negative. So a maximum here, it changes from positive to negative. Your maximum would occur, yes? And same thing here, except for the minimum is going to occur when it goes from negative to positive. So here it goes from negative to positive. That's when you're going to have that minimum. Questions? All right.